Application of DC transmission. In the case of long cable connections over the break-even distance of about 40 to 50 km, DC cable transmission system has an advantage over AC cable connections. Example of this type of application were Gotland and Sardinia schemes. The recent development of voltage source converters and the use of rugged polymer DC cables with the so-called HVDC light option are being increasingly considered. An example of this application is 180 MW direct link connection in Australia. Bulk power transmission over long distance is an application ideally suited for direct DC transmission, and it is more economical than AC transmission whenever the break even distance is exceeded. Example of this application abound from the earlier Pacific interior to the recent links in China and India. The break-even distance is being effectively decreased with the reduced cost of new compact converter station possible due to the recent advances in power electronics. Presently, the number of DC lines in a power grid is very small compared to number of AC line. This indicates that a DC transmission is justified only for specific application. Although advances in technology and introduction of multi-terminal DC systems are expected to increase the scope of application of DC transmission, it is not anticipated that the AC grid will be replaced by a DC power grid in the future. This is the type of HVDC link. This one is monopolar link. A monopolar link has one conductor. It uses either ground or C return. A metallic return can also be used where concerned for harmonic interference and corrosion exists. In application with DC cables, a cable return is used. Since the corona effect in a DC line are substantially less with a negative polarity of the conductor as compared to the positive polarity, a monopolar link is normally operated with a negative polarity. This is the bipolar link. A bipolar link has two conductors, one positive and other is negative. Each terminal has sets of converters of equal rating in series on the DC side. The junction between the two sets of converters is grounded at one or both ends by the use of short electrode line. Since both poles operate with equal current under normal operation, there is zero ground current flowing under these conditions. This is a homopolar link. In this type, two conductors having the same polarity, usually negative, it can be operated with ground or metallic return. Due to the undesirability of operating a DC link with a ground return, bipolar links are mostly used. A homopolar link has the advantage of reduced insulation cost, but the disadvantage of earth return outweigh the advantages. Thank you.